Okay, now in this video we're going to be taking a look at negative exponents. So 5 to the second, and we know that's 5 times 5, that's 25. But what if it's 5 to the negative second? Would that be negative 25? No, that's wrong. When you have a negative exponent, okay, this is why I've been underlining it. Think of it like this, it's like the 5 will need to switch from the numerator to the denominator, and then its exponent becomes positive, and then I fill up the numerator with a 1 if it is empty. Okay? And what's 5 to the second power? It's 25. Okay, so 5 to the second is 25. 5 to the negative second is 1 over 25. Okay, and it works the same way. If I have 3 to the second, that's 9. 3 to the negative second, I would transfer the 3 to the denominator so its exponent becomes positive, and that would be 1/9. It's really just the reciprocal. And here's why that is. Okay, let's say I have 5 to the 4th divided by 5 to the 8th. So let's say I do this a long way and write out all the factors. So we know that those cancel. So the top is out. Now whenever the top ends up being empty, we need to fill it in with a 1. So I have a 1. In the bottom, there's 4 5s, 1 over 5 to the 4th. Okay? And as you can see, if I done this the quick way, I would have went 5 and then 4 comma 8, and I would have minused them, but 4 minus 8 is negative 4. So that's why 5 to the negative 4th is equal to 1 over 5 to the 4th. That's a concept, but and we're going to be doing this kind of the same way as yesterday, but we need to add a box in the middle. Okay? So I need to make 3 boxes. I didn't give you a lot of room here, did I? Okay, all right, that's okay. So underline that. And our base is 8, negative 3. Now there's going to be a negative exponent. You multiply just the same way. Now it's negative 6. That's it. Now, do you have a negative exponent in that power? Yep, so you need to transfer the 8 to the bottom, and its negative exponent goes to positive. And then you need to fill up the numerator. You can't have an empty numerator. You need to put a 1 there, okay? And then next, you just find out what 8 to the power of 6 is. 262,144. Now let me explain why there's a third box, a box in the middle. If you need to check all your powers. If any of the exponents are negatives, they need to be transferred to the other side of the dividing line, okay? So that their powers become positive. Okay, so again, did it the same way, but I recognize, oh, that exponent's negative, so I need to transfer the 8 to the other side of the line, and this exponent goes positive. Now the 1's there because I need to fill up the numerator. This box and this box are the same as the last packet. It's just this one. Okay, so let's look at this one. So I'm going to make 3 boxes here. I didn't give you a lot of room. Sorry about that. So I've got x in the numerator. There are no numerical bases. And then x in the denominator. I don't need to write the same letter down twice. So I have negative 3, comma 7. All right, now I'm going to take a piece of scratch paper and figure out what I'm going to do with those. And I'm actually going to make a circle between the numbers because we're going to start seeing negatives. Be easier with the circle. Okay, so this first x was on top in the numerator. Put a T, and this other x was on bottom. When you go top to bottom, you minus. So what's negative 3 minus 7? It's negative 10. Okay. So this x has a power of negative 10. X to the negative 10th power. So, is that power negative? Yes, so the x needs to transfer to the other side of the line so that its power can become positive, and we fill the top up with a 1. And I really can't do any simplifying, so that really is just the answer. Okay. All right, next problem. Do you have any numerical bases? No, those are exponents. What letter base do you have? You have y. And you have another y on bottom. Don't need it twice. And then you have a 4, comma, and then there's another y with a negative 11. Okay. So I need to figure out what I'm going to do with 4 and negative 7. Okay. Well, the first y is on the numerator, top, and the other y is in the denominator on bottom, so again, that's a minus. Now, 4 minus negative 7, you can make that plus plus, or you can just think of it like that, and that's 11. So cross that out and put 11. Now, that y, did it have a negative exponent? No, the exponent ended up positive, so I do not move it to the bottom. I want to keep it on top. And you don't need to put a 1 on bottom. You can have the 1, you can have that bottom be empty. You have to put a 1 if the top's empty. So y to the 11th. All right, next up. Again, sorry about the lack of workspace. Underline that. Okay, numerical bases, we have 3. We have, and then that's it. So for variables, we have x, we have y, and we don't have any bases on bottom whatsoever. Okay, so 3, I have 1, so 1 needs to be multiplied by 6, and that's 6. X, 2 times 6 is 12, and then 3 times 6 is 18. Okay, now 3 to the 6th power, is the 6 negative? Nope, so keep it on top, don't move it. X, is that power negative? Nope, keep it on top, don't move it. Y to the 18th, is that power negative? Nope, keep it on top. All right, and then 3 to the 6th power. You need to simplify, so 729 times x to the 12th times y to the 18th. Okay, next up. Underline it. Okay, any numerical bases? Nope. And variables, we have m and n. Okay. M, I take 1, so 1 times negative 2 is negative 2, and then n, or no, n is not to the 1, I'm sorry. It already had a 3. So 3 times negative 2 is negative 6. Sorry about that. Getting a little lazy here. N is to the 4th. 4 times negative 2 is negative 8. Okay, so did the m's exponent end up negative? Yep, so transfer it to the bottom. Did the n's exponent end up negative? Yep, transfer n to the bottom, and then the negative exponent goes to a positive. You got to remember to make the x. Don't just put m on bottom, but keep it negative 6. That's not going to work. You move it to the bottom so that its exponent can be positive. I put a 1 on top, and 1 over m to the 6th times n to the 8th. Okay, next problem. Underline. Okay, any numerical bases? Y to the 4th times z to the 2nd times y to the negative 3rd times z to the negative 5th. I don't think I have any numerical bases, like number bases. Okay, now letters, I have y and z. So the y, there's 2 of them, both. So I got a 4 and a negative 3. Okay, so what am I going to do with 4 and negative 3? Well, both those y's are in the numerator. They're both on top, so I need to add 4 to negative 3, which is 1. Okay, so y ends up to the 1 power. Okay, now the z, I have a 2 and a negative 5. Okay, so 2, negative 5. And both those z's are in the numerator on top, so you're multiplying them, which means add the exponents, and that's going to be negative 3. Okay, now the y, did the exponent on the y end up as a negative? No, it's 1. It stays the same place. Did the z exponent end up as negative? Yeah, so you need to transfer the z to the other side of the dividing line so that the negative 3 goes to positive 3. And you really cannot simplify those, so that's the answer. Okay, x to the 5th power times y to the negative 8 divided by x to the 5th times y to the negative 6. Okay, any numerical bases? Nope. Variable bases, I've got x. On top, I got y. And then on bottom, there's x, but I already have that on top. And y, I already have that on top. Once again, don't write the same. If you already wrote the base on top, you don't need to put it on bottom. You need to put it on bottom if it's a new base that did not appear on the top. Okay, so x, I got a 5 and a 5. Well, that's top to bottom, numerator, denominator, so that's dividing, so that means we subtract, and that's actually 0, so we can cancel that out. Okay, y, we have negative 8 and negative 6. So I got to figure out what I'm going to do with negative 8 and negative 6. Okay, it's numerator top to bottom, so that's dividing, so that means we subtract. Negative 8 minus negative 6. You can also go plus plus on the double negative. And that's negative 2. So the y is to the negative 2. So we only had one base, y. Did its exponent end up negative? Yeah, so you need to move it down so it becomes positive. And you can't have an empty top. You need to put a 1 there. So the answer is 1 over y to the 2nd. Now I get some more room, and that's nice. Okay. All right, numerical bases on top. I have 12. I have A. And I have B. On bottom, I have 21. You got to put 21. A, I already have A from the top, and B, I already have that from the top. So 12's to the 1, not in parentheses, so just to the 1. A, I have 2 of those. I have a negative 3, and I have a 2. So what are we going to do with those? Okay, the first A comes from top, bottom, so that's dividing. So we need to subtract the exponents, and that's negative 5. Okay, B, we have a 9 and a negative 5. Again, top to bottom, so that's dividing, so we need to subtract. But since we're subtracting a negative, we're actually going to end up just adding 5, and that's 14. So B is to the 14th power. And the 21 is just to the 1, so that's what it'll be. Okay, so let's look at 12. Did the power end up negative? No, it did not. Keep it in the same spot. A, did its power end up negative? Yes, it did, so it needs to transfer to the bottom. B, did its power end up negative? Nope, stays on top. 21, was that power negative? Nope. So key. Now, some people are going to be like, well, you move it to the top. No, you don't move it at all. If it's a positive power, it stays in its place, but you want to put it right here, okay, in front. So 12 to the first is 12 times B to the 14th. And then 21 to the first is 21 times A to the 5th. Now, that'll work for an answer. If you're really ambitious, you can reduce 12 and 21 by 3, and that become 4 over 7. So 4 times B to the 14th over 7 times A to the 5th. Okay, again, when I'm simplifying exponents, I like to look at this. So I've got, on top, I've got 8, and then E, and then F. On bottom, I have 18. I need to put that down, and then E I already wrote, and F I already wrote. So 8 is to the 1. E, there's 2 E's, okay? We have a negative 4 and a 1 down here. If it didn't have a power, it's a 1. So negative 4, comma 1. So what am I going to do with negative 4 and 1? Well, the first E's on top and the other E's on bottom. So top to bottom, I'm minusing. So it's going to be negative 5. Okay, how about the F? We have a -2 and a -5. Okay, again, top to bottom, so you're dividing, so you're going to minus those two. And then if you're minusing a negative, that's just like adding a +5. That's 3. Okay, and then 18 to the 1. Okay, so 8 to the... Okay, so let's look at the 8 to the 1. That's positive, keep it in the same place. That's negative, you need to transfer the e to the 5th. E down the bottom, so it's 5 becomes positive. F to the 3rd, keep him in the same place, on top, on the same side of the line. 18 to the 1st, keep him on the same side of the line. Okay, so 8 to the 1st is 8 times F to the 3rd. And on bottom, 18 to the 1st is 18 times e to the 5th. Okay, 818. You can leave it like that. If you're ambitious, you can reduce it. You can reduce it by its greatest common factor, which would be 2. So it'd be 4, and that'd be 9. 4 ninths. Okay, you can underline if you want. I always like to see where my line's at, so I just underline it. So my base is 7. And then variables, I have C and D, and I do not have anything on bottom. So 7's to the 1, so 1 times -2 is -2. C is to the 7th, 7 times -2 is -14. And then D, 2 times -2 is -4. Okay, did that 7 end up negative? Excuse me, did that 7 have a negative power? Yeah, so it needs to move to the other side of the line, and that -2 becomes 2. Okay, C, does that have a negative power? Yep, it needs to move to the other side of the line, and that -14 becomes 14. Okay, the D, move that to the other side of the line, and that becomes 4. And once again, whenever the numerator on top ends up empty, we need a 1 to cover it. So that's 1. 7 to the 2nd is really the only thing I can figure out. That'd be 49 times C to the 14th times D to the 4th. Okay, next one. Underline it so you have your line, so you know where your dividing line's at, because you are might need to move things under there now. Okay, so I have 5, G, and H. Okay, 5's to the 1. 1 times -3 is -3. G is to the 4th. 4 times -3 is -12. And then H, -3 times -3 is 9. Okay, did I have a negative power? Yep, you need to move it to the bottom so it becomes positive. Negative, move it to the bottom, becomes positive. That was not negative, so we don't move that to the bottom. We need to keep that on top. So I have H to the 9th on top, 5 to the 3rd, 5 times 5 times 5, that's 125, times G to the 12th. Okay, next up. Okay, it doesn't look like we have any number bases on top, but I have an A and a B. I do have a number base on bottom 2, and then a B, which I already have, and an A I already have. So A, we have 2 of those. We have a 3 and then a -4, so we got to figure out what we're doing with those. So 3, -4. This comes from top, this comes from bottom. So I will subtract the -4, which means I add +4, and that's 7. So the A is to the power of 7. Okay, B, I have 3 of those. I have a -6, I have a 10, and I've got a 3. Okay, so I need to really analyze what I should be doing with those. Okay, from the first two B's are come from the top, and then it moved down to the bottom. And we add, because that's multiplying, so it's adding the exponents, and then dividing means we're subtracting. So negative 6 plus 10 is 4, minus 3 is 1. Okay, so B is 1. Okay, and then the 2 is to the 1. Okay, now did the A's power end up negative? Nope, it stays on the same side. How about the B? Nope, stays on the same side. 2 to the 1 would be stay where it's at. Okay, so 2 to the first is 2, and that's pretty much all you do. Now you need to pause the video and do 1 through 8, okay? And then come back to the last two. The last two are pretty easy. Okay, hopefully 1 through 8 went okay. Now here's how you do 9 and 10. Now, it says y plus 6 to the second power. Now, if you have a sum or a sign that represents a sum or difference, you don't want to make these 3 boxes, okay? You do not want to do it that way. A sum of two, a binomial squared is what that's called. Here, I'll write the term. Binomial. It's binomial because there's 2 terms, okay? The plus separates 2 terms. A binomial squared, what you need to do is drop the second power and just make another y plus 6. And then it's the 1-2 process, the FOIL method. So if you want to put 1, I'm not going to put 1s even. So y times y, y times 6, 6 times y. Here, I'll write FOIL. You don't need to write that, you kind of. And then 6 times 6. Okay, so that's y to the second. That's 6y. That's 6y. And that's 36. Okay, so you got blank y to the second plus blank y plus blank. So I have y to the y to the second would be 1. 6 plus 6 is 12. And 36. All right, once again. The plus means you have a binomial squared. So you do not want to use the 3 boxes. You want to lose the exponent, make another x plus 2. Then do the FOIL method and collect like terms. So x times x, x times 2, 2 times x, and 2 times 2. So it's x to the second, 2x, 2x, and 4. Okay. So that's done. The FOIL's done. And then blank x to the second plus blank x plus blank. So we got 1x to the second. 2 and 2 is 4. And we got 4. Okay, another one. That's a binomial squared. Works the same with minus. Drop the exponent and make a make a copy of the second binomial. Trinomials 3 terms, binomials 2 terms, and it's a binomial squared because it's the second power. So 3x times 3x, 3x times negative 4, negative 4 times 3x, and negative 4 times negative 4. So that's going to be 9 with x to the second, negative 12 with x, negative 12 with x, and 16. Okay, so blank x to the second plus blank x plus blank, so we have 9. Add these, you get negative 24, and then 16. So yeah, again, when you see binomial squared, you need to use that. All this other crap that you did on 1 through 8, those are not polynomials because there's no pluses and minus signs, okay?